This is the CisLunar Experience, episode number 8. I'm your host, J. Vincent Maroli. Today we have a pretty awesome guest on the show, Joel Sercel. Sercel?
Joel Sercel.
Sercel. Francais?
It's let's call it European.
Okay.
And the story behind where the name comes from is a little complex.
Okay.
But Slovenian, French.
Slovenian and French. Fun little combo there.
Mm-hmm.
So Joel, you are the CEO of TransAstra, cutting edge new space company that's trying to push the bounds of asteroid collection and harvesting and all the precursors that take us from where we currently are towards that day of harvesting asteroids.
That's right.
And this is our good friend Scout.
That is Scout.
This is the Labrador Doodle?
Golden Doodle.
Golden Doodle for the audio listeners. He'll be hanging out with us. So yeah, welcome to the show, Joel.
It's a delight to be here.
Appreciate it, man. So I think a good way to start off, vision, strategy, tactics. When did you first get like the space bug? When did that get bit?
When I was a very small boy, sitting by a campfire in the desert with my father, with the Milky Way spread across the sky.
Yes.
And when he explained that each one of those dots was a sun, or some of them were galaxies full of billions of suns.
Crazy.
And that Milky Haze was billions of stars in our own galaxy. And a lot of them, and back then, we didn't know how common planets were.
Sure.
So a lot of astronomers in those days thought that planets would be relatively rare. So I think my father said something like, and a lot of them could have planets like Earth. Now we now know that most of them do.
Yeah.
And
what
then
desert? Is this like out west?
This is the Arizona desert.
Gotcha.
My father was a Air Force fighter pilot,
No
flying
way.
in those days out of Luke Air Force Base.
Gotcha.
And then the other thing is, in the late 60s, I was a little kid, and Star Trek was running.
Nice.
And I got to stay up like 2 hours past my bedtime to watch first run Star Trek.
Beautiful.
And in terms of demeanor and comportment, my father was a little like Captain Kirk.
Okay.
And so somehow I always made this connection between the two guys.
Dad is Kirk.
That's right.
I love
That's
it.
right.
I love it. Confident, go take risks.
Yeah, and he was a war hero.
Yeah.
And he really liked that show, and the idea that you could. I don't know how much of the mural is on camera right now.
We get a little bit,
A little bit.
and I'm
So,
definitely going to take some photos and hey,
Nice.
look, this is what the mural looks like.
Cool. All right. But the idea that you could sit, that someday people will fly between the stars, whether those stars, between the twinkly objects in space, which could be planets,
Sure.
or the stars, was incredibly thrilling to me.
Yeah.
And so I kind of always, and I had extremely, one thing, there's a trait that runs in my family that we have really good eyes. And I remember looking at the moon and seeing structure on the moon, and then later with binoculars seeing more,
Yeah.
and feeling very much that I'm standing in the desert. There's some rocky spires over there, and I can see rocky spires there. So I think this idea that the Earth is a place and space is different never occurred to me.
Oh, I like that.
So we're all denizens of the universe. We live in space, but most people don't think of it. And I never thought of the fact that we don't live in space. I mean, as soon as I was cognizantly aware of where I was, space was where I was. Oh, I'm on the planet Earth, but there's the moon, there's the planet Jupiter, there's the Milky Way galaxy. This is where we all are. And, geez, it's a real shame that we're stuck on this one planet. We need to fix that.
Yes.
So it never occurred to me to work on anything else or be anything else.
And this was from like 7, 8, something like that.
This was from as early as I can remember.
Wow.
Being aware.
Okay. Oh, I love that. So yeah, I mean, my dad was an Air Force pilot as well for many, many years. Yeah.
Really?
Trained on T-38s and some of those.
Okay.
But then his main, sit down, puppy. His main plane was the C-130.
Got it.
So cargo missions, etc.
Right. I've spent time in C-130s. My niece is a
Yeah.
C-130 pilot.
No
She's
way.
I think she's a major now, with thousands of hours of C-130 time, combat experience.
Let's go.
Yeah.
Oh, I love that.
Yeah.
And I remember growing up hearing stories from him where he had, he's a pilot in the Air Force. Of course, he wants to be an astronaut.
Right.
And so he had sent off applications. I think he did one or maybe two at least, and got rejected.
Yeah.
Because back then, and the more I learned, to be an astronaut in the 70s, 80s, 90s, you had to be not only incredible vision and amazing health and a test fighter pilot, you also had to be able to do all these other things, because if you're going to go to the space station or whatever, you have to be able to fix things. So you got to be basically an engineer and basically understand botany. And like so he got rejected from that, which was a shame. But years later growing up, he told me, he's like, so it turns out a lot of the major astronauts got rejected like 7, 8,
Yeah.
12 times.
Yeah.
And so I remember him telling me, like, just, keep taking your strokes.
Yeah.
Keep on getting out there. So it was a pretty encouraging message from him even before touching space.
Yeah.
And then I wandered on to space camp in Huntsville, Alabama, and left that going, space.
Nice.
I have to be a part of this.
Right.
So that was a little bit of your vision from when you were really young.
Mm-hmm.
How did that trajectory go?
Well, as a young man, as a boy and a young man, I read a lot of science fiction,
Sure.
and then that got me into science fact. So
Yeah. What were some of like the pivotal science fiction?
I was really into Arthur Clarke.
Okay. Yeah.
Read everything that Arthur Clarke wrote within weeks of its publication when I was old, except for the ancient stuff, which I read prior. Arthur Clarke called me once, called me from Sri Lanka at 4 a.m. one time.
Okay.
Yeah.
And he got in touch with you somehow? Like,
So
what's that story?
So I used to have a column in a little magazine called Ad Astra. This was in the 80s.
Okay. Good phrase.
This was when NASA was doing, I think it was in the 80s. It had a commission. I think it might have been headed by a former NASA official named Payne. And they were looking for ideas for what NASA should do in space for its next great adventure. People are saying, well, we should go back to the moon. We should go to Mars. We should visit an asteroid.
Yeah.
I thought, no, what we need to do is we need to build spaceships. Build spaceships that are capable of doing more than one mission, and learn how to operate spaceships. There's Scout.
Yeah.
Learn how to operate spaceships so they don't have to have a massive team of 300 controllers on the ground.
Right.
Make them autonomous spaceships. So I said the ships that should be built in the model of nuclear submarines.
Okay.
So it should have its own machine shop. It should have its own power system. And so that got me into nuclear reactor design. So I actually designed some big multi-megawatt nuclear reactors to power nuclear-powered spaceships that could go anywhere in the solar system.
How many people are normally like on a nuclear sub?
Well, a nuclear sub has a big crew.
Okay.
Different. And what it worked out to be is that you could build a ship of, I called them ships of space, that would be roughly the size of the space station with a crew of half a dozen folks.
Okay, gotcha.
And it could get anywhere in the inner solar system out to about Jupiter with round-trip flight times of about 5 years.
With nuclear?
With nuclear electric propulsion.
Gotcha.
But these would have to be...
Here, pull this guy a little, just so
these would have to be full-scale nuclear reactors, not the little ones that other folks plan.
Yeah.
And you could really do some nifty stuff with it. And I was inspired by this 2001: A Space Odyssey.
Yeah.
And Clark had written a book called Lost Worlds of 2001,
Okay.
which was a compendium of all his notes and his different trials when he was writing the screenplay and the book with Stanley Kubrick.
Gotcha.
And in the book, I came across this quote, which I thought was very powerful, which was, let me see if I can remember it. I'll probably mess this up, but it was something along the lines of, along the corridors of the century, the roar of the rocket merges now with the creak of wind-taut rigging. For somewhere in the world today walks the boy who will be the first Odysseus of the space age. And I found that very powerful. So if you think about 2001: A Space Odyssey, the hero was Bowman.
Okay.
Odysseus was an archer. So, and I thought, there is no Odysseus of the space age yet. So what I did was I proposed a program to NASA called Odyssey.
Gotcha.
Based on 300 megawatt nuclear electric spacecraft.
Okay.
With the idea that the multi-billion-dollar push should be to develop these spacecraft that are affordable to operate. And then NASA would build a fleet of 6 to 12 of them and send them off. And I identified a bunch of missions. There would be a mission to the inner solar system,
Cool.
where they would go to Mercury and Venus.
Yeah.
There would be a mission to Mars. There'd be a shakedown mission to the moon. And then the ultimate mission would be the mission to the Jovian system.
Nice. Nice.
Now, of course, the conservative engineers at NASA read it, reviewed it, and they said, well, the physics is correct. You could do this in principle.
Sure.
But here are all the practical reasons why you couldn't do it. And it's the sort of practical reasons why you can't do things like build an electric car. You can't vertically land a rocket. Practical reasons that have to do with the fact that if failure is not an option, then
Right.
doing anything interesting is also not an option.
Yeah, I used to really like that quote from NASA.
Yeah, so I tell people when I go to NASA headquarters and I see these posters with that quote, failure is not an option, I want to get a Sharpie and write on it, therefore neither is success.
Right. It's
Right? Therefore, let's do nothing.
that's the only way.
Like, here in the lab, if you walk out in the lab, you'll see a bunch of broken parts. You'll see melted solar absorbers.
Nice.
And I tell everyone in the company, our policy is all knobs to the right. You haven't broken something this week, you're not working fast and hard enough.
Yes.
So if you wait until you follow every regulation, every dot every I, cross every T, you'll just never get there.
Yeah.
Or when I used to teach systems engineering, I taught a section on how to manage risks on progress on
Nice.
projects. And I'd say, now, normally risk management is about managing risks for cost-effective execution.
Okay.
But you need to understand that there are two proven ways to take no risk on a project. What are these two proven ways to eliminate all risk? About 10% of the time, someone in the audience would raise their hand with a thoughtful answer. There are two ways to eliminate risk completely.
Don't do the thing.
Do nothing
Yeah.
or spend infinite resources. So what government agencies are motivated to do over time is to spend more and more to do less and less until they spend everything to do nothing, because they don't want to take risk.
Yeah.
This is why the Senate launch system, the SLS,
Yep.
just the overruns on the SLS are probably more than SpaceX has paid for the full development of the Starship, which is a 30-year or maybe 50-year more advanced system.
Fully reusable, vertically landing, just better in every way.
Yeah. Now, don't get me wrong. I have some technical quibbles with the design of the Starship.
Sure.
I think there are some features in the Starship that are equivalent to the Falcon wings on that one Tesla car.
Okay.
But the fundamental approach and technology is it's the kind of thing that's impossible to do if you don't want to take risk. But if you don't want to take risk, you're not going to do anything interesting.
Yeah. One, it's two things there. One is their internal model of waste steel, not time.
There you go.
Love it. The other side of
time
this,
is much more expensive than metal.
Oh my gosh.
Time is more expensive than computers.
Yeah.
And time is and therefore PowerPoint is much more expensive than rocket. So government
Flesh that
agencies spend
out.
more on PowerPoint than they do on hardware.
In
Making
time.
PowerPoint presentations to each other, debating issues.
Yeah.
And by the way, usually when you're debating an issue, flip a coin, it's fine either way. When I used to teach systems engineering,
Yeah.
more to the executive crews, I'd teach decision heuristics, how to make decisions.
Okay.
And I said, most decisions that people agonize over are easy. Here's a couple of easy kinds of decisions. Well, it's a really close call. Typical bureaucratic response is, therefore we need to study it. No, if it's a really close call, you use your gut. You flip a coin, you make a decision.
Yeah.
Another kind of decision is, there's a big difference. Right. So we need to study it. No, there's a big difference. I will use my judgment and we'll go with that.
Yeah.
And those are the ways that technical leadership works to be cost effective.
I like that. Well, and like thinking of,
By the way, a lot of people say
Sure.
when you're a senior executive, the hardest thing is decision making. 99.9% of all my decisions are easy as
Yeah.
a CEO.
just make a decision, and if it fails, doesn't matter, because you've got 15 other decisions that you've
That's
made
right.
in the past hour and a
That's
half.
right. And the one thing you'd never want to do is have your team waiting for a decision.
Hmm.
And in my career, I've spent many, many years working in different government agencies or big organizations where people don't know what management's view is. They're spending all their time in the waiting place. That's nowhere to spend your time.
Yeah. Well, and we had a guest on the show, Lieutenant General retired Stephen Quast.
Oh, Steve is a good friend of mine. Killer is the best.
He was fantastic. And that was episode 4.
Nice.
And one of the things he talked about is on the same subject matter. It's like, not only is time important for the company development and for decision making, it's also the only way to protect your intellectual property.
That's right.
Because China will get it. China will find a way into your company through some back hardware or some ITAR something secret.
Yeah.
They'll get it. But if you've made so many decisions that what they, pull out of you is 15 iterations ago or 200 iterations ago, then they won't be able to catch up.
Yeah, that's true when you're dealing with cheaters.
Right?
And Steve and I have discussed that on that
Yeah.
exact topic on multiple occasions. And
Sure.
I generally agree with him at the 90% level.
Okay.
However, at TransAstra, we patent like hell.
Okay, sure.
And the reason is a lot of our competitors are not complete thieves. They're decent companies that are
Mhm.
competing in the same area.
Yeah.
Or, American and European companies and that sort of thing. And when you innovate
Mm-hmm.
and you anticipate it being a big business, it's a good idea to patent it.
Yeah.
So we are doing about 1 patent a month right now.
Wow.
We've got 5 so far, and we've got another at least 12 in the pipeline that have been pending.
Because those take a while to get going.
They do. There is what's really cool is the patent office does have a fast track process that we make good use of. You pay a little more, but you can go faster. You can
Okay.
usually get something closed within about a year or so.
Okay, nice.
Yeah.
From initial sketches to this is TransAstra's, nobody take it.
Yeah, so from our process from initial sketch to a filed patent takes weeks.
Okay.
It's a lot of work to write a proper patent. Some of our earlier patents we didn't write them very well.
Sure.
We're getting better at that.
Do you do all that in-house, or do you have a patent team that
We've got some fantastic innovators and inventors in the company.
Cool.
And we have one of our senior advisors, used to be a senior advisor, now he's our director of innovation, is Dr. James Small, who's a PhD laser physicist from MIT, used to be a professor of medicine at the University of Arizona,
Okay.
has about 40 patents in the area of radars, and he and I are together on about 30 patents that are pending right now.
Wow.
But he's done so much patenting that he writes up our patents internally, and we get them sort of at the 90% level before we give them to a patent attorney.
Nice.
And the patent attorneys usually find some little things to fix, and then they submit.
Okay, yeah, that's definitely a fast track there. So,
Yeah.
okay, so
Yeah, but if you
Please.
have junior engineers directly working with patent attorneys to try to get decent patents written, they can cost a lot.
Yeah. Yeah. Okay. You got to know what you're actually writing down there.
Yeah. By the way, there's an irony there, right? Why do lawyers make so much more than engineers? In a world where literally everything that keeps you from shivering in the dark came from an engineer.
Yeah. Yeah.
Wouldn't engineers be paid a lot?
You would hope.
Yeah.
So, yeah, I guess that's a good tie in there. So, want to talk about like your own personal vision in space, and then that'll probably move straight into TransAstra. But one direct connector there is, right, if lawyers are paid so much more than engineers, as we expand out onto the moon, let's just assume, Starship and others, but Starship gets green check mark. We're delivering 100 tons to the lunar surface in the next, call it 5, 6, 7 years. Fantastic. As that economy develops, in the not too distant future, there'll be permanent settlement once power and all these other things get solved. Are there certain roles that you think are just going to be kind of left behind on Earth, and others that will be in high demand expanding out onto the moon?
No.
Okay.
No.
Is there an order of operation?
As Buckaroo Banzai said, wherever you go, there you are.
Okay.
Humanity will bring humanity with it.
Yeah.
And the roles that we have in humanity are a function of who and what we are as a species. So, let's see, there's probably some maybe forest ranger.
Sure.
Okay. But if you look directly over your head,
O'Neill Colony,
you see an artist concept that our our head of R&D, Phil Wall, put together on the mural, which is our take on a world built in space with a forest on it that needs a forest ranger.
That's fair.
So I think space will not. I can't. Just sitting here right now, I can't think of any job that there is on Earth that there wouldn't be in space. It's not space that's going to get rid of those jobs. It's AI.
Okay. Robots, AI.
So AI and robots. So I would think that septic tank cleaner would be a job that would go away in the future.
For sure.
Or maybe any job that was on that TV show Dirty Jobs. Okay.
Great
in other words,
show.
jobs that people really don't want to do will go away. And then the other thing is, I think, so manual labor that's not good for you will go away.
Yeah.
Manual labor that's pleasant will not go away. And I think industries will move more towards service. And then knowledge working will move less from detailed calculation and more to judgment as a result of the Moravec Paradox.
What was that paradox? I'm not sure of that one.
So Hans Moravec is a roboticist who was at, I think, Carnegie Mellon for many years as a professor there.
Gotcha.
Now he's the CTO of a company called Sigrid Robotics.
Gotcha.
And he is responsible for something that's referred to as the Moravec Paradox, which is the harder it is for a human to do, the easier it is for an AI to do. That which humans do naturally and intuitively is very hard to program in AI. So, for example, it's pretty hard to learn to be a grandmaster at chess, but AIs are pretty good at learning chess.
They really are.
Learning the skill to manipulate algebra equations and do those, solutions that, like people like me spent until 3 a.m. every Thursday doing homework sets at Caltech. Ooh. That's actually, I remember when I was a grad student, that's when Mathematica came out. That was a big deal, right? But it's hard to make a robot that can read a person's face or tell if you're in love. And it's hard to make a robot that can appreciate art, understand art, the intuitive spiritual stuff. The closer it gets to that, the harder it is to program.
Although there was a pretty wild change in the past month or so. What was it, DALL-E 2? It was like this AI that just full scale creates artwork Are you familiar with this?
Yeah. We are moving up the stack.
Hmm.
And, as we move, cognitive processes other than consciousness, I'm not as we move up that Moravec Paradox stack, eventually robots and AI will be able to do everything that people do.
Sure.
But the unpleasant jobs that they're good at will be the only ones that go away.
That's fair. That's fair. So okay. So if we're going to take humanity with us, where do you want to take us to? Like, what's your own personal vision? And then let's start with vision and work it down to strategies and the tactics TransAstra is using to make that a reality.
Well, first start of the right, straight on till morning.
Fantastic. Yes.
So where we want to go, a whole bunch of stupid aphorisms are jumping into my mind today.
Yeah.
How about to infinity and beyond?
It's not a bad one. Big fan.
Or how about just wherever the hell we want to go? Wherever there isn't a biosphere or another intelligence to mess with or another higher biological species that might evolve into intelligence, we ought to go. The most interesting thing about the universe that we've observed so far is life.
Yeah.
And the most interesting form of life, which sounds very anthropomorphic, anthrocentric, maybe pre-Copernican, is human life. Yeah. And it's worth protecting and defending. And, we're the only entity that we know about so far in the universe that has the spark of the creative in it. And so people speculate that there are millions or billions of other intelligences in the universe. That's just wild speculation. And we have no data.
Yeah.
Zero. And the theories are just theories.
Yeah.
Science begins with data. Anything without data is pre-scientific speculation.
Yeah.
I think it's just as likely that the universe is teeming with life as it is that we're the only ones in the universe. It's
not a popular opinion.
Until we discover, if the scientific process was a demographic popular process, we would be in the cave.
Yeah.
Fair. That's not how science works. Although today's peer-reviewed publication process is getting that way, and that's slowing science down a lot. But the goal here is fundamentally humanist. It's human first.
Sure.
We need to protect the environment of the Earth, protect the biosphere, because it's where we live, and it's what gave rise to us. And when we appreciate the beauty of the biosphere and the exquisite, profound importance of it, which is why we protect it, but we protect it based on our human values. So the reason to go into space is to have a sustainable, infinite, growing future for our species and whatever its progeny are. So the destination is wherever that species and its progeny wants to go, ethically and morally.
Gotcha.
And what I mean by ethically and morally, in part, is don't mess it up for future generations, and whether those are future generations or of humans or something else.
Track. Yeah, I mean, it's baked into our DNA, right? Like maybe there's other intelligent life out there, maybe there isn't. But at least with our sample size, we versus any other life on Earth, we explore. And we say, oh, what's over that hill? What's across that stream?
Yeah, there are many, many other species that do that, but no other species does it to the extent or with the quality that we do.
Yeah, fair.
And And the idea that we'd be restricted to this little dust mote floating in the cosmos is ridiculous.
Yeah. I love it. Yeah, I mean, the amount of resources out there are they are infinite. I heard recently, I was talking with some of the other guys over at Honeybee Robotics.
Cool.
And one of the comments that just rocked
Chris Zachney and Hunter.
Yeah, I had both of them on the show.
Oh, nice. They're great guys.
They were really good.
And really good engineers.
Yeah.
Total respect to that company.
Love it. One of the things that Chris pointed out, he was like, you know what is actually a really rare element or material in our solar system? It's not diamonds. It's not gold. It's not platinum. It's not wood. Wood's pretty rare. Bone's pretty rare. Things that are connected to life. And it's just an interesting idea.
That's a great perspective on
right?
it. I thought you were going to say nitrogen.
Nah.
But nitrogen is rare in the inner solar system other than on Earth.
Okay.
But it's plentiful in the outer solar system. Lots of, the Jovian, the gas giant planets and that sort of thing. But it's interesting that wood and bone both have a lot of nitrogen in them. Nitrogen is the material that's going to be very precious for space settlers until we're able to dip down into atmospheres to collect it easily.
Just because of the fertilization that nitrogen provides?
We're made of protein requires nitrogen.
Huh.
And there's not a lot of nitrogen on the moon or in the asteroids.
I have not heard
It's
about
the thing
this.
it's the thing that, if you're thinking in the 50, 100 year time frame, it's a scarce resource.
Okay. Yeah, we've got ample power.
We used to say water.
Everywhere.
We used to say water.
Right.
But we now know that water is pretty plentiful in lots of places.
Yeah.
You just have to not be dumb about it and look at the plains of the moon near the equator where the sun shines all the time.
Yeah.
That if you're going to look for water there, that wouldn't be a good spot to look.
That's not a good spot.
Yeah.
Although there are theories that there are larger pockets of water subsurface, even at the equatorial regions of the moon.
Yeah, I wouldn't be surprised.
That'd be pretty nice, just the way that I think it's based on past comets with water hit it, and then they get covered up.
Yeah.
But again, we need, without data, it's just speculation.
Yeah, well, we do have a lot of data on the moon, and we have models.
Yeah.
So that's more than speculation.
Right. South Pole kind of area, lots down there.
And that's a lot more than speculation. Of course,
Right.
the North Pole, I prefer the North Pole to the South Pole.
Okay. I have heard this as well.
But it's not a big difference. It's not worth arguing about.
Okay. Is it mainly because of the inclination of the craters, or?
So the topology of the North Pole is a little bit less foreboding than the South Pole. Shackleton Crater is really horrendous topography.
Yeah.
I think the best speculation as to why NASA and others focus on the South Pole that I've heard is two theories. One, Shackleton Crater got a great name. Two, because people were looking for interesting things that require interesting topography, some of the spacecraft that went and did science missions to the moon flew closer over the South Pole than the North, so we have higher resolution data. And so it's kind of a self-fulfilling, self-perpetuating cycle. But my sense is, and this is not a done deal.
Sure.
My sense is that topography is a little bit less foreboding on the North Pole, and that there are plenty of places with water at both poles.
Yeah. Yeah, I heard that a while ago. It was it LRO, Lunar Reconnaissance Orbiter, if I'm doing this right, the Near Rectilinear Halo Orbit. Boom. Big word bingo.
Wow.
That they got into with the moon center and, halo up and down. They got significantly 2, 3, 4, 5 times closer to the South Pole than up at the north.
Yeah, so the resolution of the data is not as good.
Yeah. So there, we know there's water at both, but end result, we're going finally. So we're getting up there.
I hope so. Let's say we've been promised this before.
We have. So, okay, if the larger vision is let's create and enable the tools that allow us to go wherever the hell we want as humans, Yeah, what are the steps that TransAstra is taking to get us there?
Well,
What is its personal
so
vision?
we started with the vision. We started with the question, what's the most important thing to do in space for the long-term benefit of humanity?
Hmm.
And quickly came to the conclusion, or basically based on a lifetime of research and
Sure.
interest, that the most important thing for the long-term benefit of humanity in the ethical good, in the greatest ethical good, is to learn to harness the resources of the asteroids. People say, well, why is that? I mean, the total mass of asteroids is only like 4% that of the moon. Well, why is that such a big deal? The answer is you can access those resources without going into gravity wells.
Yeah.
And gravity wells suck you down into the gravity well.
They suck.
They do. And they're distributed from asteroids that are spiraling into the sun. Probably as we speak, there's an asteroid spiraling into the sun. Well, maybe not at this moment, but let's say this year there's an asteroid spiraling into the sun, all the way out beyond Jupiter or beyond Pluto. And most people think of the asteroids as just the belt between Mars and Jupiter, but that's just not true. And we know that there are 1 billion, plus or minus a factor of maybe 3 to 5, 1 billion near-Earth asteroids. These are asteroids that cross close to the Earth in their orbits.
Whoa.
If you go down and include asteroids that are small as a large truck.
Okay.
And most of them are small.
Yeah. Like bags of gravel loosely held together by like saran wrap.
Could be, or they could be chunks of rock.
Okay.
I think that there's spin data that suggests that certain sizes have different cohesiveness, but I don't want to get into a deep discussion of that right now.
Okay.
So for the long-term benefit of humanity and our progeny, the trick is to tie into those asteroid resources. And yes, it's only 4% of the mass of the moon, but it's all right there on the surface.
Yeah.
And it's wherever you want to go in space, there are asteroids nearby. And so if you can learn to harness that resource, it's a tremendous resource. Remember when I was a teenager, Gerard O'Neill calculated that there was enough material in the asteroid to build worlds to support a population of 3,000 times that of the Earth. So in 2013, I checked the calculation, and it's only 1,000 because our models of how many asteroids and what their masses were different. We've refined the models since.
Oh, gotcha.
So it's only 1,000 times. You can only build worlds out of asteroids with 1,000 times the carrying capacity of the Earth.
Okay. Only 1,000.
So that's roughly 1,000 years of exponential growth for our species.
So
that's the only way you get to a population of 1 trillion people. So take, for example, Mars. So, if Mars, the carrying capacity of Mars is 0. The carrying capacity of asteroids is 0 right now. Either one requires technology to convert it into a livable world.
Right. Both have issues with gravity.
Both have issues with gravity. It's much easier to create a 1G gravity environment in a world made out of asteroids than on Mars.
Oh yeah.
And we don't know that biological humans can live at anything other than 1G
for the long term. Yeah.
Right. And if you forced me to bet, I would probably bet that we can.
Yeah.
But you don't make plans on the basis of, hey, I forced you to bet. And what we do know is that human beings are really bad at any environmental effect that they're not adapted for through natural selection. So like plastics in the environment and pesticides and other chemicals in the environment right now are wreaking havoc with mammals and reptiles around the planet, including human beings, physically changing our anatomy. That's scary. That's just plastic in the environment. That's not living at a gravity level that's different than we've been adapted for 1 billion years of evolution.
Yeah.
So there's a good argument to say, and in bioethics, you don't do experiments with large populations of people just for fun.
Understandably.
So if I'm thinking, where could I go in space and certainly be ethical? Asteroids are the place to go, because I can make Earth-like environments where I can simulate 1G but with spin.
Yeah.
I can provide radiation shielding with the regolith, and I
Okay.
can provide an Earth-like atmosphere.
Yeah.
And it may be that you can do that on the moon and Mars. So you'd build a city and spin the city on the moon to create more gravity.
Maybe.
Yeah, it's not out of the question, but it seems unrealistic.
Yeah. You said the asteroid belt has the capability of, at current calculations, about 1,000 times. So, 8 billion times 1,000. Was that 8 trillion?
Yeah, it's 8 trillion, but you'd want to live at a lower population density we have now.
Okay.
So I
Okay.
say 1 trillion.
Okay. Fair. So
Because everyone should have 5 acres.
that'd be nice. People like that.
That's right.
Are those calculations just with the asteroid belt, the most recent, like the one between Mars, Jupiter, and the ones around it?
Well,
Or does that
quantitatively, the
include-
vast majority of the asteroid belt is that asteroid belt that people think of. So
Okay.
the other remnants of the asteroid belt that are spread throughout the solar system are rounding errors.
Okay. Isn't there like a couple different rings though? Like there's the asteroid belt, then there's like the Kuiper belt,
Oh, yeah.
and then way out you got the Oort cloud that's
Yeah.
something. Are
Yeah,
tho-
I'm not including any of those
Okay.
in the calculation. And frankly, I don't know how much material is out there. I have
Yeah.
to go to a planetary scientist for that
Yeah.
information.
and they might not even.
And no one, and actually no one knows. There's estimates.
Yeah.
But we have really good estimates of how many asteroids there are, because
Gotcha.
you can statistically sample space with telescopes. And
Okay,
then you can
okay.
estimate the total population. You can develop power laws which is like a mathematical equation with an exponent in it
Gotcha.
for estimating how many asteroids there are of different sizes. We know about their taxonomies of what they're made of. We compare that to meteorites. We have a pretty good idea of what they're made of. So within error bars, and everything in science has error bars. If you're not thinking probabilistic and in error bars, you're really actually not thinking scientifically.
Gotcha.
But within error bars, we know what the asteroids are made of.
Mhm.
And
and what are those made of? There's like 4 different main types, right?
well, there's a bunch of different types, and
Okay.
I don't want to get into the taxonomies, but
Okay.
and we actually can map those types, interestingly, to where they were created in the primordial disk that formed the solar system. And we actually have computational models of the solar system that run backwards in time to the
Gotcha.
early formation of the solar system, the accretion of the planetary disks, and you can use those models there are good correlations between those models and the distribution of materials in the asteroids and what their taxonomies are and what they're made of.
Gotcha.
One of my former students at Caltech, a guy named Dr. Bill Botke, is
Okay.
probably the leading expert, I think, on that, if not certainly in the top 10.
On taxonomy of asteroids?
No, on the evolution of the
Ah.
asteroid distribution, and especially the Neo belt.
Gotcha.
So he and a guy named Gronvik from Europe and a guy named Jedicke from the University of Hawaii have a mathematical model of the distribution of material in the Neos
okay.
that they publish in Nature periodically.
Gotcha. Of those near Earth
It was originally
asteroids.
called the Botke model, then it was called the Gronvik model. Hopefully the next one will be called the Jedicke model, but I don't know. So Jedicke is a good friend of the company and a shareholder in the company
Okay.
and an advisor to us. We work with him on our telescope technology for prospecting asteroids.
Gotcha.
So the reason I think it's the right choice is in the long term, you know that there are no biospheres. It would be incredibly unlikely to have advanced life evolving on asteroids.
Yeah.
So you can go there without killing things.
For sure.
It's like, and then, whereas there is this huge unknown about life in the solar system. Oh, there's our front door ringing at the Hive, getting a FedEx delivery.
Got some background.
That's cool.
Yeah.
So let's see, where was I?
So expanding vision statements, why asteroids are important.
Yeah,
Don't kill people.
Yeah, so don't kill people or life that could evolve into interesting things.
Yeah.
And like the biggest scientific unknown is life.
Sure.
Like we literally know nothing about it. People who think there's a lot of life in the universe think, well, clearly there's life on Mars. And then other people say, well, let's go build a city on Mars. before we know if there's life. That seems really irresponsible to me. So let's send, let's say, 1,000 robotic probes to probe Mars before we propose building a city on Mars, just to kind of make sure.
Yeah. And in that process, you get sample data from, I mean, the probes can move.
Right.
So millions and millions of different
Right.
locations.
Right.
Now we know
that
the
would
best
be
place.
now that would be a tiny fraction of the data that we have about the Earth.
Right.
And still we're discovering new places on Earth where life lives
Yeah.
that we didn't think it lived. So that wouldn't be a lot of data to rule out life on Mars, but it would be enough to. And if there is life on Mars, I've heard people say, well, if it's just microbial life, who cares about that? What? What?
No.
Like microbial life that is different than Earth? Like there's two interesting possibilities. It has DNA similar to human DNA. That would be a scientific revolution of biblical proportions.
Yeah, absolutely.
Or it's completely different. Also a scientific revolution of biblical proportions.
Yeah.
And so there are some well-known space advocates. Oh, it's just molds and oh my gosh.
What if it's mushrooms? Who cares?
Yeah. I like mushrooms.
Yeah,
right.
they are tasty for sure.
So that's why the asteroids. And then, but we're not a company that's just pie in the sky vision.
Okay.
We're about real business here and now.
Gotcha.
If you can't make money on it,
right,
it's not worth pursuing.
because there's been other
It's
asteroid
just
companies.
science fiction. That's right.
They've tried. It looked really pretty, and I've heard some inside stories of different predatory investors out there that hijacked companies and things of that nature. But
I haven't heard that.
fun stuff.
Okay.
I forgot all the names anyway.
Okay.
So whenever I hear stuff like that, I'm like, and dump the name so I don't accidentally.
Okay.
But point being, those asteroid companies didn't succeed.
Yeah, so our business plan doesn't depend on asteroid mining.
Okay.
That's our vision.
Gotcha.
Our business plan is very practical, pragmatic, and near term.
Nice.
So what happened was we started to develop a suite of technologies as a vision-driven company years ago, mostly under NASA NIAC fellowship sponsorship, NASA NIAC sponsorship.
Which is government money that says, describe NIAC for us.
So NIAC stands for the NASA Innovative Advanced Concepts Program. It's the place in NASA for funding the wild inventions that could totally change the art of the possible and make things radically different.
Nice.
NIAC is a wonderful program. And I remember I have a colleague who's a very seriously, very respected scientist who I brought to a NIAC symposium once, and he was sitting listening to all the presentations and taking notes and everything. And I was a little worried because he has to survive in this peer-reviewed science world where if you like, let's just say they're not super excited about any new idea.
Yeah.
And I was like, well, what, Rob? What do you think? What do you think? And he said, are you kidding? This should be 90% of NASA's budget, not 0.01% of NASA's budget. Yeah. But NIAC is a very exciting program. It's very competitive. But unlike everything else in NASA, where they give you a very specific problem, they have a solution in mind, and they ask for a proposal for it.
Yeah.
They just say, we want proposals for technologies and mission concepts that will change everything. Nice. So that was the perfect place for me to go.
Yeah.
So we started writing proposals to NIAC a few years ago, and we've been incredibly successful. I think I've been awarded 7 NIAC fellowships, which is more than anyone else in the world.
Wow.
And we've brought in something like $4 or $5 million of undiluted funding from them, which is what we use to pay for proving our inventions, and that's that patent. That's what's funding that patent pipeline.
Gotcha.
And then last year we got serious about fundraising in the private sector and raised a few more million of venture funding, and we've collected something like $7 million of private sector seed funding.
Cool.
And
but that's such an advantage as a founder to a company that we've got a ton of this tech fleshed out. look at all the non-diluted, look at all the capital we've already raised,
Right.
air quotes, from NASA. Now when you go to the VC world, you can put forth the valuations
Yeah.
that you believe in, or at least a lot closer towards that without giving away 50%.
Yeah, and you know what's really exciting is it's difficult to communicate it in a PowerPoint presentation or a pitch or something, but every investor that's come to the Hive has invested. Because once you see the technology that's in that laboratory behind us,
Yeah.
and you understand what its near-term financial potential is,
Hmm.
you invest. We've had people that we're in talks with, you know, I'm going to invest X, and by the time they're 2/3 of the way through the tour,
Mm-hmm.
they've upped it to 2x. So
Wow.
the exciting thing, so we started developing the Sutter technology
Cool.
to find the asteroids.
Okay.
So we have, if you look on the mural up here,
Mhm.
there's the Sutter Ultra artist concept. Sutter Ultra is a NIAC concept
Okay.
that's a low-cost approach to discovering asteroids in space.
Because currently we just have the number based on models, and they're good models and they're predictive models.
No,
like you
no,
were
no, no,
saying
no. We
earlier.
know where 30,000 asteroids are. Something, don't quote me on that
Okay.
number. Something
Okay.
in that round number. So we have a very good statistical sampling of the asteroids.
Okay.
So and their asteroids are discovered every night on
Yeah.
telescopes.
But those tend to be larger ones.
They tend to be larger main belt asteroids, which are pretty easy
Gotcha.
to find because they don't move too fast relative to the background stars. But when you're looking for these near-Earth asteroids, they move
Gotcha.
faster relative to the background stars because they're closer.
Okay.
And those are the ones that we're after for mining purposes.
Hmm.
And there really hasn't been a survey that's been well focused on them.
Hmm.
And the approaches that have been taken have been very sort of old school approaches. So we invented the Sutter Telescope technology to find hundreds or thousands of times more asteroids.
Nice.
The issue is we know where the vast majority of them are, larger than 1 kilometer. You know, sort of the dinosaur day, you know, the day that ended the dinosaur asteroids.
Right.
Or larger than 100 meters, sort of, you know, civilization ending
Yeah.
event kind of thing, or city, or take out a city or
City
a
killers.
state, that kind of thing. But we don't know where even a tiny fraction of asteroids sort of the size of a house are.
Hmm.
Those are potentially dangerous, but they're not considered formally PHOs, potentially hazardous objects.
Okay.
And I think it's largely because they're too hard to find, because they're too faint.
Right.
So we
We'll
designed
label it.
the Sutter Telescope to find those, and
Yeah.
especially to find those that are at low delta V from the Earth. Delta V is how we measure how hard it is to get
Gotcha.
between places in space.
Dig into that for a second, right? Because that's one of the other main benefits of near-Earth asteroids versus asteroid belt, right?
Exactly. The asteroid belt is really hard to get to.
Okay.
When I was a young engineer at JPL, there was a holy grail mission that NASA wanted to do called the Main Belt Asteroid Rendezvous, MBAR. And it was like $1 billion class mission that they wanted to do, and they couldn't get the money to do it. And actually, there's a brilliant electric propulsion engineer named Dr. John Brophy at JPL, who was working on an ion engine that could propel objects and spacecraft less expensively.
Yeah.
And I had a management position at JPL. Recently, had completed my PhD, and he came by my office and we were chatting one day, and I said, "Hold it! What if we take this N-star system and derate it? That means reduce the power level of it to make it less risky.
Got it.
And instead of using it to make a mission that's unaffordable, a mission that's like technically impossible,
Yeah.
possible but still unaffordable, let's take MBAR, which is technically feasible but too expensive. Let's make it cheaper." And we were able to show that you could launch the Main Belt Asteroid Rendezvous mission on a smaller rocket and make it much more affordable. And that led to the N-STAR program, the NASA Solar Electric Propulsion Technology Application Readiness Program, which I'm guilty of making up that acronym. But it was the first
That's a
deep
hard
space
one.
flight of ion propulsion.
Gotcha.
And
When was
then
that?
That was in the early, we proposed it in the early 90s,
Okay.
and it flew in the 90s.
Gotcha.
And then that led to the Dawn mission, which was a discovery mission that did the main belt asteroid rendezvous.
Gotcha.
Used the N-star ion propulsion system to rendezvous and orbit around the asteroids Vesta and Ceres.
That's right.
Anyway, it's so you need a expensive, fancy electric propulsion system to cost effectively get to main belt asteroids, just like NASA is going to do with Psyche,
Right.
to go explore a metal asteroid that's further in the solar system.
But
hard
again,
to get to.
That's just poking it.
That's just poking it.
That's-
It's not bringing it back.
Yeah.
So it'll be decades and decades before we're doing practical mining of main belt asteroids.
Okay.
But we know that we can calculate statistically that there are thousands of asteroids that have return delta V's less than the surface of the moon. So there are energetically nearest, that means easiest to get to partners, objects in space.
Yeah.
They're energetically, even though they're out in deep space, they're energetically between geostationary orbit and the moon.
Wow.
But of those thousands, we only know where like 10 are. Because there are small asteroids that are too faint and fast moving to be found with conventional telescopes.
Gotcha.
So we invented the Sutter Telescope, which is named after Sutter's Mill in California, where they found gold. That led to the gold rush. So we named it after that.
Great name.
So we've calculated that the Sutter Ultra mission will find in its first year of operation more than 300 times the number of asteroids found in the entire history of astronomy. And over a 10 to 15 year history, we'll find essentially all of the NEOs.
Wow. Is the goal to manufacture multiple of these Sutters?
The idea is to fly 3 Sutter telescopes in a
Okay.
special type of orbit that we've innovated. Other people have considered orbits like this, but not for this purpose. It's a special orbit where the telescope would circle the Earth, but it wouldn't be in orbit around the Earth. It would circle the Earth at a distance of about 10 million kilometers, which is outside the Earth's gravitational sphere of influence.
Okay. So beyond the moon, right?
Yeah, the moon is about 250,000.
Okay.
So this is this is 10 million. So it's significantly beyond the moon.
Significantly.
And it's actually in orbit around the sun in an elliptical orbit that makes it circle the Earth. It's a mathematical, interesting thing.
Yeah.
And so that's just the right distance to find asteroids that are flying within a few million miles of the Earth.
Okay.
And we would put 3 Sutter Ultra spacecrafts. We'd put 3 Sutter Ultra spacecraft in those orbits. So there was always one between the Earth and the sun looking out. So that as a camera, it has the sun on its back. So it's perfect for seeing asteroids. And that would really create a gold rush to the solar system, because it would find thousands of mineable asteroids that are energetically closer than the moon. But we realized that the exact same technology can solve a very practical commercial problem right now today, which is space domain awareness and orbital traffic management.
Okay.
There are thousands, there are millions of pieces of space debris, but we only know where tens of thousands of them are.
Sure.
We need to know where the space debris is, and we need to know where lost spacecraft and derelict spacecraft or hidden spacecraft are. And the Space Force and NASA and the Air Force have acute interest in that. Also, anyone who wants to operate a constellation and not collide with other objects.
Yeah.
So we are now deploying the Sutter telescopes in observatories around the country and having really great success seeing faint moving objects with it.
Just from ground surface looking
From ground
up.
surface looking up. And then we're demonstrating the technology so we can fly it in space. So our roadmap is to continue deploying the network now for today's commercial operations, then move to flying it in space for demonstration purposes to help maintain space domain awareness in CisLunar space.
Yeah.
And then we have a concept called Sutra, which is the Sutter technology applied to CisLunar domain awareness for the Space Force.
Okay.
And we would fly 3 Sutter Ultra spacecraft in CisLunar space. And with that, we'd be able to maintain constant contact, essentially, with every spacecraft in CisLunar space down to the size of a toaster oven.
Okay. So I was about to ask, what's the resolution on these guys? Because I've heard talks from other groups Orbital Composites is one. We had them on the show.
Nice.
They want to manufacture massive radar dishes and other things in space.
Cool.
Because they say, hey,
that's the way to do it.
Constellations only will get so far.
That's right.
You got to have big things that you can't launch.
Yep.
So, if you're deploying the same thing in a terrestrial observatory as a very similar model, I'm guessing, up out in space, do you have a massive dish, or like how are you getting?
No, these are small, cheap telescopes.
Okay.
So we've shown that with lots of small, cheap telescopes are a lot cheaper than a few big telescopes.
Okay.
So
launched from.
So let's say that I had a single 4-meter reflector. Okay. That would cost at least 1,000 times as much as a single 30-centimeter reflector. And I can fill 4 meters of aperture with about 100 30-centimeter reflectors.
Okay.
So building 100 30-centimeter reflectors is 10% of the cost of building one 4-meter reflector. And you don't need big pieces of glass for finding asteroids. You need to search a large volume of space looking in all different directions at once. So it's way more cost effective to do this with a compound telescope, which is why Sutter is based on compound telescope technology.
What is a compound telescope?
A compound telescope, have you ever seen in a science magazine or something, like a picture of a bee's eye?
Yeah.
That's a compound eye.
Okay.
So it turns out that a lot of things in our technology there's this weird stuff that tends to be related to bees. So what we've found is that if you really want to maintain situational awareness in space, lots of small optics beat a few big optics every time.
Gotcha.
So a compound telescope is one that's made of a lot of little telescopes. The little telescopes can be manufactured very cheaply using mass manufacturing technology.
Sure.
And you win big time in terms of performance per unit dollar, the number of objects you find per unit dollar. And our calculations show, and actually the table I think is on our website, show that it's 300,000 times more cost effective than a single monolithic telescope for finding lots of objects in space.
Do you have to?
By the way, there's lots of other technologies,
Yeah.
some of which we talk about, which is on the website,
Okay.
some of which we don't, and some of which is patent pending.
Roger that. We'll if we ever touch on the patent pending, just be like,
No, patent pending
sorry.
we can talk about.
Okay.
It's the stuff that's you don't want to patent, but it's a trade secret that you don't talk about.
We'll keep that under wraps. So wait, so if a bee's eye, for example, is a compound lens.
Yeah, in this case, they're compound reflecting telescopes.
Compound reflecting telescopes. A bee has all those different things right next to each other.
Right, and that's how ours are also.
Okay, so you guys will manufacture, mass produce 100, 1,000 of these
Take
things.
a look at that art image up on the mural. You see all the little elements arranged in a hexagonal configuration?
Yeah.
That's 109 30-centimeter telescopes, all integrated onto a 4-meter diameter platform that can be launched in a single Falcon 9. In fact, we can launch 3 of those in a single Falcon 9.
So you manufacture the large device that holds it.
The spacecraft.
The spacecraft that holds it.
It's a medium-sized spacecraft.
Okay. And then you just place, while still on the ground,
109 telescopes on it that have been manufactured, mass manufactured. That's not actually mass production, but it's a big enough number. Making 300 telescopes is a big enough number that you can invest money to get the recurring costs down, and then you can produce them vastly cheaper than the sort of one-off optics that are often flown in space.
Okay, gotcha. And you don't have any of the issues of unfurling.
No unfurling, no deployment, none of that kind of stuff.
Gotcha.
Which those are all risky things. There's no moving parts on that spacecraft to speak of. There's one filter wheel. And I won't get into the details on that.
Okay.
But the spacecraft moves by rotating the whole spacecraft to sweep the fields of view of those telescopes out in space. There's a really cool video that we made.
Okay.
That you can check out on the website. If you go to transastra.com, go to videos and look for this animation of Sutter and how it works. All of this is explained.
Gotcha.
It's much easier to explain with video and images than verbally.
Fair enough. Okay, so this guy is going out there. This is the near-term, cost-effective way to.
So the near term is right now we're deploying a constellation of telescopes for space domain awareness that we're selling commercial products for helping people find things in space. That's super near term.
Okay.
By the way, we'll also start finding asteroids with those. As we do, we'll be selling NFTs for asteroids discovered.
Okay, wait. Yeah, let's go into that. So wait, the NFT.
No, that's all I'm going to say about that. That's a teaser.
Okay, fine. Let it be teased. Follow TransAstra to get the NFT drop.
That's right.
So the near term.
I kind of said that because we're looking for NFT partners.
I know a guy over at Copernic Space.
Nice.
So connect. We shall.
If you know a guy who knows a guy, find the guy.
Gotta find the guy.
Yeah, there you go.
So, so one question more on that. So I'm sorry, what was the name of this guy with 109?
Sutter Ultra. It's
Sutter
the ultimate
Ultra.
version of the Sutter Telescope.
Gotcha.
Less ultra version is over there.
Okay.
I have 4 of those 30-centimeter optics on a single Worker B1. Worker B1 is the orbit transfer vehicle that we're building out in the lab here.
Yeah.
So Worker B1 is a very, very inexpensive orbit transfer vehicle that uses water as propellant and just sunlight as the power source. Now, a lot of people say they use sunlight as a power source in space, but the way they do it is with big, expensive solar arrays.
Right.
The way we do it is with very inexpensive solar reflectors that are vastly more efficient than solar arrays.
Okay.
And they just concentrate the sunlight right onto our engine. It's called the omnivore engine.
Okay.
And basically they heat it up really hot. Hot as
the sun?
We can't get quite as hot as the sun. We can only get to about a third that temperature.
Still pretty toasty.
Pretty darn hot.
Okay.
And then we...
and that like evaporates the water?
Well,
or sublimates it?
Yeah, it vaporizes the water to super high temperature vapor, which is then squirted out the back to produce thrust. And so we've got the cheapest rocket propellant, the safest rocket propellant, but 10 times the thrust of an electric propulsion system for a fifth the price. So we're faster, cheaper, higher performing, safer. That's the commercial advantage. And we can fit 25 Worker B1s on a single Falcon 9, and each of them can deliver 6 satellites to their orbital destination. So we can put a full constellation of 150 satellites spread through all different orbits in low Earth orbit on a single Falcon 9 launch. So we can deploy a global constellation in one launch, and the full constellation is deployed in a matter of weeks. The millions of dollars that saves our customers is very attractive to them, which is why we have $400 million in letters of intent and MOUs for orbit transfer services.
Okay. And so these satellites that you're taking with you, so it's the Worker B1, the front has just the optics, and then on the back half.
So Worker B1 is over this shoulder over here.
Okay.
That's Worker B1.
Okay.
Behind me and above me.
Track.
See the 6 little boxes on that?
I do.
Those are 6 small sats.
Gotcha.
That's Worker B1 carrying 6 small sats. What we don't have on the mural is 25 Worker B1s, each carrying 6 small sats.
Okay, sure. Multiply out.
That's 150 satellites, right? So, but if you're not carrying the small sats, then you can do what we're doing over there, which is carrying 4 Sutter telescopes.
So the base.
So 4 is a little bit of a magic number for us because our current compound telescopes that we have deployed at observatories carry 4 telescopes each. But the ultimate is Sutter Ultra that carries 109, and that's a bigger, more capable system that comes later.
Track. Okay. And so for efficiency's sake, not only are you taking 6 small sats from other customers and distributing them all across the orbits, but is the base machinery, is the base box the same?
It's the same type of Worker B that can carry the small sats versus the Sutter telescopes.
Gotcha. Just swap out the
and then
fixtures.
It doesn't have to be 6 small sats. It could be one big small sat that's maybe 400 pounds.
Okay.
It depends on what the customer's satellite looks like and where they want it deployed. So let me just put a bow on that. So our realistic current commercial activities are commercial telescopes for space domain awareness, which is an existing market
Right.
that we're deploying a network of those right now.
Okay.
And then there's the Worker Bee orbit transfer vehicle, which is for delivering small sats in low Earth orbit. Worker Bee 1 is a small system, really well designed for satellites in the CubeSat to 200 kilogram range. Provides well over a kilometer per second of delta V. I won't say exactly how much well over, but
Sure.
it provides a very healthy delta V.
Okay.
And it can do things like carry satellites from GTO to GEO.
Gotcha.
Or it can deploy satellites in low Earth orbit to different inclinations or different local times for the ascending node, LTANs. We also have a roadmap of larger Worker Bees, Worker Bee 2, Worker Bee 3.
Okay.
Sutter Ultra is designed to be compatible with Worker Bee 2,
Okay.
which is a medium class spacecraft. You can put 3 of them on a Falcon 9. And then Worker Bee 3 is a super heavy spacecraft designed to be launched into space by something on the order of a New Glenn,
Okay.
or maybe 2 of them on a Starship.
Gotcha.
So Worker Bee 3 is, we think that there's going to be a new market for super heavy geosats.
Which is interesting because the industry it went from you could only deliver super heavy satellites.
Well, I don't think there's ever been a super heavy satellite launched to GEO. I mean, they've been heavy. But, like even a really big satellite, like the biggest satellite in the world, has a 20 kilowatt array.
Okay.
That's a joke. I have a modest house about 10 miles from here.
Yeah.
It's a very modest 3-bedroom house.
Sure.
And in order to run that house, I have a 10 kilowatt array on the roof. Okay, one house.
Yeah.
Okay, so to serve all of North America, they put up a geosatellite with 2 10 kilowatt arrays, and they say that's high powered. That's why the geo market has evaporated. They haven't figured out how to really well serve and provide super high bandwidth to lots of users on the ground.
Okay.
And because comm requires power. But they're still small, low-powered systems. They're thinking very 20th century.
Gotcha.
So we see the market exploding for a much bigger class of geosatellite.
Okay.
Also, NASA and others have needs for big orbit transfer vehicles for human exploration. And so Worker Bee 3 is conceived of for that. Now, all the Worker Bees are powered by our Omnivore solar thermal rocket.
Okay.
We call it Omnivore because we now have a patent issued for what makes Omnivore omnivore.
Okay.
It's the same rocket engine is able to run on different propellants. So it's omnivorous. Whereas most rocket engines can only run on a one propellant combination.
Right.
So an Omnivore engine can run on water or ammonia or hydrazine or green propellants or, now hold it, wait it, here it comes, or liquid hydrogen. Okay, so Omnivore on most propellants performs about like a chemical rocket.
Okay.
But when you feed it liquid hydrogen, it performs like a nuclear rocket for about 1% the cost, maybe 10% on the outside.
Because hydrogen is so light that you can just put tons and tons of it in a container.
So it's because hydrogen is so light
ISP?
that the ISP goes up.
Okay. And describe that real quick because some will know and some won't.
So ISP is how we measure the equivalent of gas mileage in space.
Gotcha.
And so it's measured in the units of thrust times time, which is impulse, per unit mass of propellant. So it's specific. Whenever you say in engineering specific, it means per unit mass.
Okay.
So thrust times time per unit mass. So how many seconds can I produce, how many newtons of thrust for how many kilograms of propellant? That's what specific impulse is.
Cool.
So when you increase the specific impulse, it means you need less propellant to go from point A to point B. So the way a rocket engine works, how technical can I get?
Yeah, get some technical.
The way a rocket engine
and I'll
works,
ask what does that mean? What does that mean?
That's fine. So the way a rocket engine works is you basically put a fluid into a chamber and make it very hot. And then you squirt it out a nozzle to produce thrust. Why do you want to make it very hot? It's because the Mach number that comes out of the end of the nozzle is fixed by the geometry of the nozzle. It's the magic of fluid mechanics.
And the Mach number, like
Mach number is
speed?
it's the speed. It's the multiples of the speed of sound that it comes out at.
Cool.
Okay. So in the throat of any rocket engine,
Mm-hmm.
the flow is at Mach 1. That's called choked flow.
Okay.
Okay. And then the Mach number anywhere downstream of the flow of the throat
Mm-hmm.
is determined. It's determined by a million different things, but let's say to first approximation, is determined only by the geometry of the nozzle. Typically, the Mach number at the exit of a nozzle might be 6 or 8, something like that.
Gotcha.
So 6 times the speed of sound. So the only way to increase the speed at which stuff comes out
Mm-hmm.
is to increase the speed of sound, because it's going to be Mach 1 at the throat. If the
Yeah.
speed of sound is twice as fast, the velocity is twice as fast.
Hmm.
There are only 2 ways to increase the speed of sound of a fluid.
Hmm.
Increase its temperature or decrease its molecular weight. You're limited by materials for temperature,
Right.
and you're limited in the molecular weight of the species by what it's made, of the propellant
By
fluid, by what it's
power.
made of. So the ultimate high specific impulse rocket propellant is pure hydrogen.
That's just superheated. And
It's-
as it's going out from that nozzle, it's a wide nozzle. It
So you
gets
get
faster and faster.
supersonic flow. Exactly.
Okay. All right. Appreciate.
Sure.
Okay. So
By the way, here's a
Yeah.
trivia question
Yeah,
for
yeah,
you.
yeah.
That when I used to teach propulsion at Caltech, I used to ask the students,
mhm.
the gas that's coming out of the back of a rocket nozzle, what kind of temperature is it at? Is it hot or cold?
Scorching hot.
Because like everyone's seen these videos of the Falcon 9 in space and the nozzle's glowing red. So the gas must be really hot, right?
Must be really hot.
Nope. It's ice cold.
What?
Yeah. So what happens is it's really hot in the engine. And then the purpose of the nozzle is to convert that heat to kinetic energy. And so as
Okay.
it's expanding in the nozzle, it's like, remember you learned in grade school or high school that if a gas expands quickly, it cools.
Yeah.
So basically the pressure in the gas is pushing on the nozzle. That's what's accelerating the gas. As it's doing that work, the purpose of a nozzle is to turn the thermal energy into directed kinetic energy. So the gas that's coming out the back of a nozzle is ice cold. Then you say, well, why is the Falcon 9 nozzle glowing red?
Why is it glowing red in space?
Because there's something in fluid mechanics called the no-slip boundary condition.
Okay.
That means the gas that's actually in contact with the nozzle is not moving at all. That means it had to stop. And when it stopped, it converted all that kinetic energy back into heat.
So there's kind of like a
There's a layer
layer of
on the
film.
outside called the boundary layer. That boundary layer is not moving fast at all, and it's hot as hell.
Okay. So if you touched the outside of the rocket engine,
You would certainly burn your hand.
Yeah.
If you put your hand in the flow,
Mhm.
it would burn right off instantaneously, because the
Okay.
ice cold gas would hit your hand and stagnate, and that would convert the kinetic energy back into heat, and it would burn your hand off.
I see.
But
I
if
see.
if you had a particle that was moving with the fluid, it would be ice cold.
Oh, that is so fascinating.
So
If you were a tiny little person and you were swimming down the length of
Exactly.
the rocket and went out the back of it, you'd be frozen popsicle.
yeah, so
But if
It's-
you touch it,
so I mean, it's fun to talk about these things,
sure.
but like this is what people who don't understand math and science don't get. So they
Yeah.
like for me, looking at the universe without math and science
Hmm.
is like being colorblind. It's like you're not seeing it as it really is. In fact,
Hmm.
it's not even like being colorblind. It's like you're watching a cartoon of the universe,
Hmm.
because you can't see how things actually work.
Hmm.
And this is why, like physicists and engineers, often people say, well, he's on the spectrum. Well, what it is he just finds the universe so fascinating, and then the complexity of humans is confusing. But once you learn math and science at a young age, and it's inculcated into you,
Yeah.
then you look at the universe through equations and mathematics, and it's a completely different language and a different way to think about things.
Well, and the other thing and I'll talk to the science, because, I mean, frankly, math has never been my strong suit. Like I had the finance degree, but calculators, right?
Yeah.
That's what you use them
Yeah.
for. I've loved science though,
Cool.
ever since I was a wee little lad. And I think one of the things that like why is it that some people love writing and love music and love science, and some people just can't stand one of
Right.
those subjects?
Right. We're all wired a little differently.
Yeah.
Like I empathize with that because I have a deficit when it comes to language. I have a terrible time with foreign languages.
Okay.
And I also have a terrible time with symbolic music, translating symbolic music into music.
What do you mean by that?
Like reading music and playing written music.
Gotcha.
I can only do music intuitively. And and so I totally understand that because I have these blind spots in my brain that just don't work. So I totally get it. Like,
yeah.
And I have this weird thing that I can't talk and do math at the same time. Literally, my mouth stops working. And so it was very hard for me when I learned to teach at Caltech. I started to lecture the way other people did, and it just didn't work. So what I'd have to do is I'd have to put all the equations in a PowerPoint in advance.
Yeah.
And then I would pretend to be reading the equations, but I wouldn't actually read the equations because if I actually read the equation, my brain would stop working.
Oh, that's super interesting.
So I'd point at the equation and not look at it. But I knew what the equation was, and I'd talk about the equation as though I was looking at the equation.
I love it. You got to find the ways that work for you. Like
Exactly.
for science, it takes a lot of imagination to like get science and understand it. And you have to just ask a bunch of questions. Like someone first described to me like entropy and how heat is distributed and all this stuff.
Right.
It's like, let me break it down to the really, really simple terms. You've got a ball and you're holding the ball and you drop the ball. And when that ball hits the ground and bounces, imagine the ball's a little hot. And when it's a little hot, it hits the ground and it shakes off, and some of its heat shakes into the floor. And if it keeps doing that, it's going to do it to the point that it's cold. And when it's cold, it doesn't really want to move anymore. And that's a gross approximation, but like good enough to start with. I think it's science. It just takes people being inquisitive, saying, "Well, why is that? What is this going on?"
Yeah, like once you ask 5 whys in a row, you get to the point where no one knows the answer.
I like that. 5 whys, right?
5 whys lead to I don't know for just about anyone.
I love it. So talking about once you get to your 5th why, nobody really knows what's going on there. There's an element where we need to craft vision and statement for future exploration up on the moon, CisLunar space, and all of that route. Let's talk about like the economics for a moment, not just of TransAstra, because clearly you guys are doing well. You said you got the NIAC money, and now you've got money coming in the door.
From both commercial contracts and investors.
Fantastic. Yeah, both of those arms. And you said you've done seed round so far.
Yeah, we've done a seed round, and we're doing some other stuff right now.
Okay. All right.
I'll just put it at that.
Fair enough. I respect that. One of the things that Hunter William from Honeybee Robotics brought up, we started talking about how will the economy develop up on the moon. And he had a really interesting take that the current laissez-faire capitalism sort of setup that we have is actually really, really dangerous if we take it up on the moon. For example, in LA, there's someone that is pissed and frustrated at the world and says, screw all you people, and rebels by, living on the street, by burning down another guy's shack next door, whatever. The impact on the larger society, though detrimental, doesn't kill hundreds of people. If someone is in a similar situation up on a moon colony, they can craftily take a wrench and undo a couple bolts, and maybe our airlock system saves it, maybe not, but has one bad apple, has the chance of really impacting a lot of people. And so that was part of his reasoning behind, like, what elements of capitalism, go figure your stuff out, need to be left down here on Earth. So I guess with that framework, I'm curious, you said earlier, humans are going to be humans wherever we go. How do you see that economic system developing up on the moon? Is it dependent on who gets there first?
Let me first comment on, first of all, Hunter's a brilliant fellow.
Yeah.
So I met him first when he was a graduate student at Colorado School of Mines.
Mm-hmm.
He actually worked on our optical mining technology there.
Nice.
You know, he speaks Japanese.
He's cool.
Yeah. But we don't have laissez-faire capitalism.
Okay.
And what he was describing was not laissez-faire capitalism, it's lawlessness.
Okay.
And it's a failure of the government to enforce the law that allows people to do those things. So I think only a pure libertarian doesn't believe in regulation. Okay. I would say a smart capitalist believes in the minimum smart regulation to help things work efficiently. Where we get into trouble is as we move into new domains with new technology, is we don't think about it in advance and we do the regulation after the damage has been done.
Okay.
Where we get into trouble also is where we think about every possible bad thing, take no risk, and overregulate.
Yep.
So I would say that let's not let the overregulation fringe or the no regulation fringe run the show. How about let's let the common sense majority in the middle take a balanced approach here.
Fair enough.
So what we've learned from history is that when you move into a new domain, it's going to be it's literally the Old West was an example. It was an unregulated thing and you had the Old West.
Yeah.
Probably would have been a little better had the government put in a little bit more law enforcement in advance.
Okay.
Probably not the same law enforcement that you need in the middle of Manhattan, but reasonable law enforcement. And they kind of did, but it was a little late. Okay.
Like with the bounties and warrant system.
Yeah, all that kind of stuff. You know, I don't want to go into that, but
yeah.
And then
Old West style.
Yeah. Likewise, like internet. Right now, we have tremendous problems with psychological disease associated with not knowing how to properly manage and regulate the internet.
Yeah.
Some people want to lock it down. Then we have people who have fairly extreme views controlling what the quote truth is.
Yeah.
That's pretty scary.
Yeah.
That's a result of not having thought it through in a systematic and orderly way. If you go to my LinkedIn profile, you'll see a paper. You'll see an essay titled "To Boldly Go Where No One Has Gone Before, Responsibly." That was co-authored by Steve Quast and myself.
Gotcha.
Where we get into this. How can we learn from history and bring those lessons forward? By the way, if you look over there, you'll see the Space Force logo.
Yeah.
So when Steve was formulating the strategy on the Space Force, I was one of his advisors.
Nice.
It was a lot of fun, and he's an awesome guy to work with.
Yeah.
Why do we need a Space Force? It's because we need law and order in space. Because without law and order, you have the kind of craziness that can happen.
Yeah.
There are a bunch of commercial space stations being, and by the way, just making laws doesn't do any good.
Right.
You need a way to enforce the laws, and you're not going to repeal the laws of human nature.
No.
And there's no selection process that you can go through and where you can say, well, we're just going to only have good people go in space.
Right.
Well, maybe your definition of good is different than my definition of good. So there are a number of space stations that are being planned, and early construction has started on the ground.
Yeah.
When we start to get hundreds and thousands of people in space, there are going to have to be security services in space. You know, the red shirts from Star Trek. You know, the guys who carry the phasers.
Yep.
And there's going to have to be a brig.
Yeah.
There's a brig on every major cruise ship. And there's a reason for that, because sometimes people get out of control. We need law. The question is, what law, what guides us?
Yeah.
And how do we make sure that we don't do too much? Now, I'm a person who thinks that the optimal amount of law and regulation is a little bit less than what you would optimize for maximizing economic output. Because I lean on the side of believing in freedom first.
Flush out the little bit less then.
Well, so if you don't believe in freedom as an important value, then you want to regulate more. If you have no belief in freedom, then you're willing to, throw people in jail for making statements against the government.
Yep.
So, we as humans can't perfectly predict what the right regulation will be. We'll get it wrong the first time.
Yeah, fact.
But let's think it through based on lessons learned. For example, I brought up bioethics.
Yeah.
Like the protocols that we have in biology for bioethics and what you're allowed to make profit on selling to people came from lessons learned from screwing it up and having entrepreneurs who maybe they were less ethical, or maybe they were just wrong. Maybe they just made a mistake, a human mistake. And they sold things to people that were dangerous and killed them or maimed them.
Gotcha.
A classic example is there was a drug decades ago called thalidomide, which was a good drug for helping people. But if women took it when they were pregnant, the babies came out badly deformed. Many, many, many children were born as a result of this. Wow. That led to changes in the regulation, the Food and Drug Administration, that said that you just can't sell millions of drugs, millions of copies of drugs without proper protocols.
Gotcha.
Likewise, it would be equally unethical to take. It's one thing to you used the word earlier in this podcast, a settlement on the moon.
Sure.
There's a radical difference between a settlement and an outpost or a base.
Yep.
So in an outpost or a base, you can have professional astronauts who are aware of what they're doing, go for longer and longer periods of time, but they don't gestate children and raise children there.
Fair.
In a settlement, you're gestating and raising children.
Yeah.
So it would be the grossest breach of bioethics for a company to make money on a settlement where people were gestating children and growing children when there hadn't been, say, 5 generations of dogs raised. Or 50 generations of mice and 3 generations of chimps with genetic diversity. Because that would be a completely irresponsible thing to do, and it would violate every principle of bioethics that we have.
Right. Because maybe
it's the sort of thing that the Nazis did
Yeah.
to Jewish prisoners in World War II. And just because you're an enlightened explorer doesn't give you a right to make a profit doing that. That's wrong. So
doesn't mean that there shouldn't be, you know, hospitals make money today and it's expensive to have a child. But having a child in one gravity has been done since the beginning.
Exactly. So if you're going to, you can't experiment. So there's every reason to believe that a child born in reduced gravity would be permanently deformed and would have serious problems.
Yeah.
And here's moreover, why did I say multiple generations?
Yeah.
The leading edge of biology is all about epigenetics. Do you know what epigenetics are?
That's like the biology example from high school is the crab that works out his claw a whole bunch. His kids get bigger claws, right?
Yeah, and when I was a kid, it was told that that's hooey.
Right.
We now know it's true.
Oh, snap. Which makes
we know, for example,
so much sense.
We know, for example, there are good quality refereed scientific papers that show that people who meditate, the process of meditation causes their children to be calmer in life. Epigenetics started with the realization that if a family goes through a near starvation event, it has effects on the offspring 4 generations on.
4?
Yes.
Whoa. Curse from...
So gene expression, so DNA is about genes, but phenotype is about gene expression.
Yeah.
Gene expression is also inherited, which means that your environment affects your children and their children. So if I take, so if I go up and raise a generation of children on the moon, it will not just affect their life, it will affect their children's life and their children's life and their children's life.
Yeah.
Now, it might be that each generation gets worse until they're just not viable.
Could be.
It might be that each generation gets better and they just adapt to living on the moon. Probably the latter,
Yeah.
but we don't know that because we haven't even done 50 generations of mice.
Yeah.
So there's a principle in bioethics that you don't profit on something with the general public that you haven't done proper scientific protocols on. So regulations should be put in place with enforcement on that so that we don't wind up doing something that's a moral outrage and a crime against humanity.
Yeah. That tracks.
Similarly, if we go to Mars and wreck the biosphere before we even know there's a biosphere there. I mean, I don't know if there's a biosphere on Mars.
Yeah.
Anyone who claims to know.
Right.
But
Maybe
we don't even know.
Yeah.
And there are serious scientists who think there is, or Europa, or other places.
Sure.
So So all the laws that we have right now, and the things we've learned from the law of the sea and aerospace law, we should look carefully at, and then we should look at history of exploration and development and bioethics, and put in place the minimal regulations that we think will keep us from atrocities.
Sure.
But I think Hunter's example of having a crazy person with a wrench on the moon is a much worse thing than a crazy person with a wrench, in a suburb.
Sure.
But there's more subtle things than that. So if you land a large spacecraft on the moon with its rockets pointed down towards the regolith,
Right.
it can put debris into orbit.
Yeah.
And that debris can be orbiting for years and then kill someone.
Then land and.
So this is stewardship of the environment. We don't.
Is it
So
ethical to have your rockets on all the way down to the ground?
And so you have to put. So I think it's perfectly reasonable for us to consider a law that rockets of a certain size can't land unless there's a prepared surface on the moon.
Seems legitimate.
If in fact the analysis that shows that it puts debris into orbit is true. I mean, we could get an orbital debris environment on the moon very quickly that makes it unnavigable.
Yeah.
Currently on the Earth, the greatest danger to an astronaut in low Earth orbit is micro debris impact on the spacecraft. Yeah. And that danger is
Growing.
orders of magnitude worse than the danger of air travel. We'd like to make space travel as safe as air travel. It's almost categorically impossible with the current debris environment. Once you get to something like the space station, which is a bigger object that can be shielded and stationary and doesn't have to move around,
Sure.
then it can be more safe. But even the space station has a serious orbital debris risk.
Oh yeah, and it's full of Swiss cheese.
Right.
It's got leaks all over the place.
Now, what I'm concerned about is the people who are interested in regulation are people that are pro-regulation. And if we over-regulate it, we can kill it.
Yeah.
So we need folks who are pro-moderate regulation.
Mm-hmm. Well, I think there's something I heard. It was about like parenting, right? I don't have a wife, don't have kids, but trying to learn. And it was what is the? How did he phrase it? I think it was Jordan Peterson. He talked about what is the correct amount of punishment to a child to inflict to teach them something. And the answer was the minimum necessary force.
Exactly.
And it's derived from English
and if
common
the
law.
child has a gun in his hand, that's a lot of force.
That's a lot of force. And if it's
Right.
one son that you can just look at him and that works, cool.
Right.
If it's myself when I'm a little kid, you got to get out the wooden spoon.
Right.
And that's what it takes.
Right.
Same thing up on space. We have to apply the minimum necessary to allow those economies to flourish.
Yeah, and things like mental health, which we have the biggest mental health crisis in history is going on right now on the planet.
Huge.
Screening for mental health will be much more important in space than it is on the ground.
Yeah, absolutely. So I guess wrapping all this sort of up, right, there's incredible things that we're trying to do out in the solar system.
Sure.
Both as humanity and as TransAstra. There's also a big risk out there right now. and it's the rising force of China.
Yeah, it's a very significant risk. Talk about unethical governance.
Yeah. Their sights are set on pretty much just domination of the lunar surface in a similar setup to what they've done on their own country.
Yeah.
From an engineer's perspective, who's in their mid-20s, still at university, listening to this show, who's starting to get a grasp on China, and if you want a more detailed thing, episode 4, Stephen Quast flushed that out beautifully on
Nice.
what the danger is. From your perspective, what can that individual do to get us closer towards this future and keep freedom the way that it should be?
Learn everything you can if you're a young person. Get practical experience. Build stuff. Get good at what you do. If you're good enough, start your own company. Get into the game.
Take those first couple of steps.
Yeah.
I love it. Well, then I guess in closing, are you guys looking for more engineers, more money? What's a forward-looking?
So right now we're
TransAstra?
staffed the way we want to be for the next few months. We'll probably be hiring in a few months.
Okay.
We are always open to investment. We do have a vehicle open for folks who are interested in investing,
Nice.
accredited investors only.
Of course.
And stay tuned for more news announcements at transastra.com.
There it is. Bada bing. Cool. Well, Joel, thanks for coming on the show.
Fantastic. This was a lot of fun.
I enjoyed it as well. I really did appreciate it. Even with Scout hanging out with us.
What do you mean even with Scout? Especially with Scout.
Especially with Scout.
Yeah.
Furry little pup we can pet. So.
Yeah, furry little. He thinks he's a 5-pound lapdog, but he's a 90-pound 8-year-old golden doodle.
He could take you out.
If he wasn't so nice.
He's very calm.
That's right.
Wonderful. Well, cheers, everybody. Ad Astra.
Bye.
Go be brave and do courageous things, because life's too short to do otherwise.
There you go.
Cool.
Nice.
That's a wrap.
All right.
Thank you, everyone, for tuning into the show. If you got some value out of this, drop us a review and a thumbs up wherever you're listening or watching this show. Check us out on the social medias. I am at Vincent Maroli. Sounds like cannoli, ravioli, all that delicious Italian food. If you have any additional thoughts or questions about the show or being a guest on future episodes, reach on out. LinkedIn, probably the best place, and I'll get back to you promptly. If you're interested in investing in space, again, Spaced Ventures, these guys have a great platform. They really do their due diligence. So be sure to head over there and tell them who sent you. And until next time, go get some blue sky, and don't forget to aim and aim high. Blessings.